Hello, I'm David Lim, and I'll be presenting my final year project, CZ3007 Compiler Techniques Lab project, and my solution, an RDP Code Generator application. The course CZ3007 Compiler Techniques is a module offered by the NTU School of Computer Science and Engineering. It explains concepts of compiler design, such as context-free grammars, lexers, parsers, and code generation. The course is continually reviewed and enhanced in order to uphold its educational standard and quality. Enhancements made should align with the curriculum of the course and contribute towards its objectives. The objectives of this project is hence to devise, develop, and implement such supplementary materials for CZ3007. My chosen approach for this project was to develop a web application to help students gain a better understanding of context-free grammars, or CFGs, and recursive descent parsers, or RDPs, which are important topics covered in CZ3007. For context, a CFG includes a structured set of grammatical rules that describe the syntax of a programming language, while an RDP is a program designed to parse source programs based on the rules of a particular CFG. Students can submit CFGs of their own custom design, and in return, the application will generate RDP code based on the specification of the CFG. Students can download the RDP code and run them on their own devices. Currently, the application can generate RDPs in 3 languages: C++, Java, and C#. The RDPs generated also use only the standard libraries of their languages, and no third-party tools are required to compile and run them. Furthermore, the application can also generate detailed reports alongside the RDP code. These reports provide a detailed explanation on how the RDP functions. The application's main objective is to help students gain a better understanding of CFG design and RDP functionalities, including the correlation between a CFG and its resulting RDP. Furthermore, by allowing students to create custom CFGs and analyze RDP code, the application offers them a hands-on and engaging means of learning that can stimulate their understanding and interest in compiler techniques. This makes the application a useful supplement to the existing CZ3007 course materials. The main features of the application are CFG processing, RDP code generation, report generation, and error handling. The application analyzes the input CFG and identifies constructs such as its terminals, non-terminals, production rules, and first and follow sets. These data form the syntax of the CFG and are hence very important for the RDP code generation, since the output RDP code relies on the structure of the grammar rules and the types of symbols accepted by the grammar. Based on the CFG data, the application generates the RDP code in various languages of the user's choice. As mentioned earlier, the languages currently supported are C++, Java, and C#. The RDP code generated follows the LL1 predictive parsing algorithm as taught in CZ3007. By comparing an example CFG to the resulting RDP code produced, one can see similarities between the two. For example, each parse function in the RDP is tied to a non-terminal symbol in the CFG, and the parsing algorithm used by the function logically follows the production rules under the non-terminal. The application can also generate detailed reports that explain the functionalities of the output RDP. These reports are generated in the form of Doxygen documentation, written in the RDP code. Students can use Doxygen to view the reports in the form of HTML pages. These reports will be valuable in helping students better understand the RDP functionalities and their relation to the input CFG. The application is also able to identify errors in the CFG input by the student. These errors include left recursion, common prefixes, and miscellaneous syntax and parse errors. Should any errors be detected, a detailed error message will be displayed that clearly states where the error occurred and the nature of the error. This allows students to easily detect and prevent such errors in the future. Using the application is rather simple. All the student needs to do is to enter the CFG, select the necessary code options, and submit. The student can then download the generated RDP code to their devices. The RDP code can be compiled and run directly on the student's devices. The RDP takes in an input file containing a statement to be parsed. If the user enables report generation, an additional Doxygen file will be generated alongside the RDP code. The student can view the report by opening a command prompt, navigating to the folder, and entering Doxygen, followed by the file name. Note that this requires the student to have Doxygen installed on their device. The report contains an in-depth explanation on the various functions of the RDP. This is especially useful for students who have difficulty understanding the RDP or who would like to gain a deeper understanding of how the RDP works. The RDP code can also be run cross-platform. For example, these screenshots show the RDP code running on Android. These screenshots also show the RDP running on a MacBook. Overall, the RDP Code Generator application helps to strengthen students' understanding of CFG design and RDP functionalities. It provides an engaging, hands-on avenue to put these concepts to practice. The application is also highly accessible due to it being a web app, as well as the cross-platform nature of the RDP code. These factors contribute to the overall value the application provides to students learning compiler techniques, as well as to the CZ3007 course as a whole. Thank you for watching, and I hope you are encouraged to learn more about the RDP code generator.